So 1.9a, absolute value equations and inequalities. So we're going to start by just reviewing what absolute value is. So remember, the symbol for absolute value would be the vertical bars. And what we're asking when we're asking for the absolute value is, what is the distance from 0? So if you looked at a number line and you look at positive 5 and negative 5, what's the distance from 0 of 5? And of course, that distance is 5. Well, negative 5 also has a distance of 5 from 0. So there are two numbers who have a distance of 5 from 0. And that's part of our reasoning for coming up with two solutions most of the time when we solve an absolute value equation. So before we get to solving the equations, let's look at just evaluating or simplifying some of these. The absolute value symbols act as symbols of inclusion, or almost like parentheses. So we do what's inside the parentheses. 4 minus 8 will give us a negative 4. Well, then we need to take the absolute value of negative 4. So the distance from 0 would be a positive number, a positive 4. And then after that we subtract 3 to get 1. So on example B, again, we're going to do what's inside the absolute values first. So I'm ignoring this negative out front. Negative 10 subtract 4 would be negative 14, and that's inside the absolute values. Taking the absolute value of a negative 14, it changes it to a positive 14. And now we can place this negative that was out front at the beginning in front of this negative 14 here. So we have negative 14 plus 3 gives us a simplified answer of negative 11. And then example C, again, ignore the negative out front, take the absolute value of negative 8 to get 8, then you can go ahead and put the negative. So we have 3 subtract 8, which gives us negative 5. So we can end up with negative answers because there can be other things in front of the absolute value that change so that we do have a negative simplified answer. Okay, now let's go ahead and solve absolute value equations. And one of the most important things that we need to remember is that the absolute value must be alone or isolated. We need to isolate the absolute value first. Once we get the absolute value isolated, we can go ahead and separate this into two equations. So write two statements, and then we will solve each equation separately. And we generally end up with two solutions on our absolute value equations, and we're going to write these inside of set braces, the little squiggly braces. So if you can't write those exactly, you can kind of do the little squiggly line. So in example A, the absolute value is already isolated, so we can go to the second step, which is to write our two statements, or our two equations. We have x minus 5 equals 3. Notice I'm not changing that minus 5 to a plus 5. The left side stays the same. The stuff inside the absolute value stays the same. The only thing that will change on the second equation is from a positive 3 to a negative 3. And again, that goes back to the fact that there are going to be two numbers whose absolute value, it was 5. There will be two numbers whose absolute value will give us this distance. So adding 5 to both sides, we solve each of these. So x is equal to 8, and x is equal to 2. Place both your solutions inside the set braces. The order that you write these does not matter. Just put a comma in between them. On example B, we need to isolate the absolute value by first dividing by 3. So we have the absolute value of d plus 6 is equal to 4. From here we can go ahead and separate and write two statements. D plus 6 equals 4 and d plus 6 equals negative 4. Subtracting 6 from both sides, we get d is equal to negative 2 and d is equal to negative 10. So our two solutions are negative 2 and negative 10. Okay, come down to example C. To isolate this absolute value, we need to get rid of this 5, and this 5 is being added to the absolute value. So the opposite operation of addition would be subtraction. So subtract 5 from both sides. So we have the absolute value of 2x plus 8 equals 6. From here, we can go ahead and separate into two statements. 2x plus 8 equals 6, and 2x plus 8 equals negative 6. Continuing to solve this, we have 2x equals negative 2. Dividing by 2, x is equal to negative 1. Solving the other equation, subtracting 8 and dividing by 2, we end up with x is equal to negative 7. So writing both of our solutions inside the set braces, we have x equal to negative 1 and negative 7. And then the last example on this page, the absolute value is isolated. And as we look at this, it says that the absolute value of this expression, so remember, an absolute value of a number or an expression is always going to be positive. So in this equation, they're stating that the absolute value of this number, which is always positive, has to equal a negative 2. And negative 2 is a negative number, so that is just not a possibility. So in this example, we don't even have to continue solving. We can go ahead and state that there won't be a solution for this particular absolute value equation. All right, now that we've had some review of solving absolute value equations, let's move into solving some absolute value inequalities. So up at the top, the notes tell us that if we solve an absolute value inequality with a less than, it's going to be an and compound inequality. If we solve an absolute value with a greater than symbol, it will turn into an or problem. And remember what those look like when we graphed those. Our ands on the number line, we had two numbers and our solution ended up being in between the two numbers. And on the or compound inequalities, we had our solutions that were usually facing away from each other. So with our absolute value inequalities, let's look at the steps. We're going to first get the absolute value by itself. So we need to make sure we isolate the absolute value first, just like we did on the equations. Then from here we will write two statements, and we'll talk about how to write those two statements. We will solve each statement, and then we will graph and write our solution set. Now our examples want us to solve, graph, and write the solution set in interval notation. So remember, interval notation is with the parentheses or with the brackets. So we have a few steps that we need to go through. So let's look at example A. So notice our absolute value is already isolated by itself. So at this point, we can now look at this symbol, which is a less than, and this will end up being an and compound inequality. When we separate into our two statements, one will be with positive, one will be with negative, and with the switched inequality sign. So our first inequality stays pretty much the same. 2x subtract 6 is less than 6. The second inequality The 2x subtract 6 remains the same. The inequality symbol will be flipped, and the 6 changes to a negative 6. So there are two things we need to do on this second statement, and that is flip the inequality and change that to a negative. Now we can go ahead and solve each of these inequalities by adding 6 to both sides and then dividing by 2 on both sides, so x is less than 6. On our second inequality, adding 6 to both sides and dividing 0 by 2, we get x is greater than 0. So if we graph this, and I'm going to graph this one first, x is greater than 0, we have an open circle. At 0, our solution goes to the right, but I'm not going to put an arrow on that because x, since this is our compound inequality with and, we also need to have this condition, x is less than 6, so open circle on 6, arrow to the left. So our overlapping or common solution would be just this space in between 0 and 6. And remember, we write this interval with our ands. We start with the left side endpoint, which is 0, and then our right endpoint, which is 6. Since both of the circles are open, we're going to use parentheses around the 0 and the 6. So this says everything in between 0 and 6, not including 0 and 6. All right. Example B. The absolute value is already isolated. Notice it's another less than, so this is also going to be an and compound inequality. We can separate the inequality into 5x plus 7 is less than or equal to 42, and 5x plus 7 is greater than or equal to negative 42. Solving each one of these inequalities by subtracting 7 and then dividing by 5, I'm getting x is less than or equal to 7 5x is greater than or equal to negative 49. Dividing by 5 gives me x is greater than or equal to, getting a fraction on this one, negative 49 fifths, I'm just going to change to negative 9 4 fifths. So remember, this is an and, so let's take our smallest endpoint, which would be this negative 9 4 fifths, and place it on the left of our number line. The larger number always goes to the right. X is greater than or equal to this value, and x is also less than or equal to 7. So our solution is everything in between negative 9 4 fifths and 7, including negative 9 4 fifths and 7. So to write this interval, we take our two endpoints, negative 9 4 fifths and 7, write those down and place the brackets next to each one of those. All right, let's go down to example C. Our absolute value is already isolated. This symbol is a greater than, so this one will look different. This will be our OR compound inequality. So we have x plus 2 is greater than 6, or x plus 2 is less than negative 6. So we flip the inequality and change that to a negative. Subtracting 2 from both sides, we get x is greater than 4. On the second inequality, subtracting 2 from both sides, we get x is less than negative 8. So when we graph these, let's start with this smallest number here. X is less than negative 8 is an open circle. Solution to the left, and then graph x is greater than 4, which is another open circle, but the solution is to the right. So here's our OR compound inequality. To write the interval for this, let's start with the left-hand side interval. So the arrows to the left, that means negative infinity to negative 8. And then we need the U symbol for union. The right inequality starts at 4 and goes to positive infinity. So a little more work to write that interval for our OR compound inequalities. Okay, example D. Separate into two inequalities. 10x plus 5 is greater than or equal to 55. This is greater than, so it's another OR. Or 10x plus 5 is less than or equal to negative 55. Subtracting 5 from both sides, we get 10x is greater than or equal to 50. Dividing by 10, x is greater than or equal to 5. Or 10x is less than or equal to negative 60. Dividing by 10 gives us x is less than or equal to negative 6. So when we graph this, I'm going to start with this smaller one. X is less than or equal to negative 6 would be a filled in circle, arrow to the left. Or x is greater than or equal to 5 would be another filled in circle with the arrow facing to the right. And then the last thing we need to do is write our interval. So this first interval would be negative infinity, comma negative 6, bracket, the U for union, positive 5 with a bracket, comma, infinity, and a parenthesis next to the infinity. All right, let's look at our last two examples. So on the first four examples, we already had the absolute value isolated. Looks like on these last two, we need to isolate first. So subtract 5 from both sides. So before we split into two inequalities, we need to make sure that this absolute value is by itself. Then from here, we split into negative 6x plus 10 is greater than or equal to 70. And this is greater than or equal to, so this is going to be an OR. Or negative 6x plus 10 is less than or equal to negative 70. Solving each one of these separately, subtracting 10 from both sides. And then this is where we also need to be careful. We're going to divide both sides of this inequality by a negative number, which flips the inequality symbol. So x is less than or equal to negative 10. On our second inequality, subtracting 10 from both sides. And again, we are dividing by a negative number, so it flips the inequality symbol. So we get x is greater than or equal to 13 1/3. So to graph this, we have, for the first inequality, we have a filled in circle at negative 10. Arrow going to the left. To graph this one, x is greater than or equal to 13 1/3 would be a filled in circle. Arrow going to the right. And then the last thing we need to do is write our interval. So from negative infinity to negative 10, a bracket next to the negative 10, the union symbol, bracket 13 1/3, comma, infinity, with a parenthesis next to that infinity. All right, our last example. So the first thing we want to do is isolate our absolute value. This negative 8 is sitting right next to the absolute value, which means it's being multiplied. If we want to get rid of the negative 8, we need to do the opposite of multiplication, which is division. So divide both sides of this inequality by negative 8. Now when we do that, it flips the inequality symbol. So we have absolute value of 6x subtract 9 is greater than a positive 9. From here, we can separate into two statements. So 6x subtract 9 is greater than 9, And we can also look at this inequality symbol to determine whether it's an and or an or. So at this point right here, it's a greater than, which means we will end up with an or compound inequality. So our second statement, 6x subtract 9, is less than negative 9. So add 9 to both sides and divide by 6 to get x is greater than 3. Adding 9 to both sides on the second inequality and dividing by 6 gives us x is less than 0. So for our graph, we have an open circle on 0, arrow to the left. That would be our x is less than 0. X is greater than 3 would be an open circle on 3 with an arrow to the right. And to write this solution as an interval, we have negative infinity to 0, parentheses, u for union, 3 to positive infinity inside parentheses.